Traversal is a fundamental operation in any data structure. Traversal is nothing but navigation of elements that are stored in the array data structure here, or for that matter in any data structure. When we try to access every element of the data structure, then we could call it as navigation or traversal. So coming to the array data structure, traversal is visiting each and every element of the array for implementing any operation that demands accessing all the elements of the array, and wherein we take an example of coming to array data structure. Traversal is visiting each element of the array for implementing any operation that demands accessing all the elements of the array. We need to traverse the array. Let's start with an example of incrementing each array element by 1. So here we are going to look into what traverse array algorithm is, so which is going to help us understand how we are going to travel through the elements that are stored in the array. So the basic idea is to visit each and every element of the array, so which is basically called as traversing the array. So the question what we've taken to understand how the traversal is basically done is increment all the values that are stored in the array by 1. Right? So we try to increment every value of the array that is stored by 1. So if we have here an array named A, which has a starting index as 0 and the upper bound as 4. Right? So here the elements that the array stores are 11, 20, 9, 18 and 15. So our idea is to take this element, pick out this element 11 and add 1 with this and make it as 12. This is what we are trying to do. And we are not going to stop with this. Instead, we try to do the same thing with all other remaining elements in the array. So in which case, the problem demands to traverse or visit every element that is stored in the array A. So how we go about doing this? So we just take A of 0, so which is the first element of the array, and add the value that is stored in the location, that is add the value 11 with 1. Right? So we increment the value that is stored in location A of 0 by 1, and this is to be repeated with all other remaining elements. So what we do is, in the next step, we go pick out the elements stored at location 1. So take the element stored at location 1, add 1 with it and put it back in the same location from where we picked. So A of 1 is equal to A of 1 plus 1, and it goes on till the end of the list or end of the array here. So same thing is being done repetitively, just using different values in the index position. If you just look at the indices at every statement, there is only change in the index value, nothing else is getting changed. So the name of the array is the same and the value that is getting added with every element is the same. That is, at every step we add only 1 to the element which we are visiting at that particular instance. So here A of 0 is moved with A of 0 plus 1. A of 1 is moved with A of 1 plus 1. So the operation or the process that we do is repeatedly done starting from 0 till the 4th location in the array. So we can go for using a loop structure in order to develop an algorithm for this process. Now let's see how we can convert these steps, which is the process done here, into an algorithm. So this algorithm will help us to traverse the list, and also once we visit a node or once we visit a particular element of the array, we can pick it out and do some operation. The process or the operation that we do here is incrementation. So do that incrementation and put it back in the place from where you have picked, move to the next location. So this set of statements will help us move to every location in the array and get access to the elements stored in that particular location. So how we start with writing the algorithm is, we need to have a index variable. So index variable here, which is going to change its value at every step, but it's going to start from 0. So we declare an index variable I with the value defined as 0 in it. Why? Because like the index value here in the array starts from 0. So we just move value 0 into I, which is going to be used as an index variable in our algorithm. So initialize I with 0. Now what is next? So once you've initialized I with 0, you get to use that index value in order to access the element. So how to access the element? So have this I as the index. So A of I is equal to A of I plus 1. So that is what we've done here. So initial value on I is 0. So we have taken A of I here, which is now 0, equal to A of I plus 1. So this statement is right. Right? So this is not going to be done only for value 0 or I, but instead we need to change the value till we go reach the end of the array. So when we start with, the value on I is going to be 0. So once you are done with the process that has to be done with the first element or the 0th element in 0th location, this process has to be repeated with a different value and index. So that value is nothing but the next immediate value of this I. The value now in I is 0. So next immediate value in I should be 1 then. So you increment it. So at every step, if you just look at the indices here, index is getting incremented by 1 at every step. So just have the statement I is equal to I plus 1, which is going to help you increment the index value. So I make I is equal to I plus 1 and I close the loop. So why I close the loop here? I don't need to do anything else because I am done with all the process that I have to do. I have to add the value, take the value, add it with 1, put it back. That has been done with the statement. And move to the next location. How are you going to move to the next location? By incrementing the index. So that is also done. And so we are going back. We try to repeat the same set of steps for the other remaining values in the array. So now with value 2 and I, we'll go back to while loop and we check for the condition. We again repeat the same set of steps with the new value in I. So this will suffice for traversing the elements in the array and also doing some process with the visited elements, right? So here in place of while loop, we can also use other language construct, that is for. So since this is an algorithm, we don't have any hard and fast rule that we have to just use while or for. You can simply say that it is a repetitive process where the value in I is going to be, initial value in I is going to be 0, and we are going to check for a condition I less than or equal to 4 because we need to just access only 5 elements. Since I starts with 0, it is enough just to go till 4. 0, 1, 2, 3 and 4 takes us or gets us 5 different values. So it is just enough to check for I less than or equal to 4. We need not go beyond 4. So 4 is the upper bound. So we need not go beyond 4 here. So we have this condition checked, right? So it is always better to use a looping construct whenever you see that a particular process is being repeated in any structure. Now let's see how actually this algorithm works. By tracing the algorithm, we can understand whether this algorithm is working fine or whether this is doing the intended operation. So now let me teach you how to trace an algorithm. So this forms the basis for understanding in any code or code snippet that is written by somebody else. So when a particular part of the code is given to you, you can always try to trace it and find out what that particular code segment is doing for us. So understanding this algorithm tracing is most important. Now let us see how to trace this algorithm that we have written in the previous section in order to understand that it does the operation that we have written for. So here the value on I is 0 and I have taken just these steps which has been written in the previous slide. We are taking the same set of values in the array, that is same example array has been taken. Now check whether it works fine. So here at the first step, so look at this part of the slide. As the first step, you initialize the value on I with 0, right? Value on I is taken to be 0, so we mark it as 0 here. This is the first step that happens here when we try to implement the algorithm, when we try to run the code. So here the next statement that is going to get executed is this while statement. So when you execute a while statement, it is not going to stop with one single execution. The while statement may or may not run for many number of times. So initially this is going to run with the value I 0 in it. So here I take that as the first step. So that we call as normally the iteration. Since we are going to go for many number of times the same statements getting repeated, we name it as iteration. So this is first iteration, wherein we check for the condition 0 is less than or equal to 4. What is 0? 0 is nothing but this value in I. We check for the value in I with that of 4. So here value in I is 0 and the constant 4 is being compared with this value 0. So here the condition is true, 0 is less than 4. So that when the condition becomes true, then we enter into the loop body. So this part of the code is called as loop body. That is, all the statements which comes inside the loop are called as loop body. So here when the condition is true, the control enters into the loop body. If not, the control will come out of the while statement. So here the condition, for our case it is true, so we enter into the while loop and we try to execute the statements in sequence from there on. So we just come to this point where a of I is added with 1 and move to the same location, right? So a of 0 is picked here. You could see here always we substitute the values in the right hand side of the expression. This is a simple mathematics here. We just take this 11 which is there in a of 0 now and add constant 1 with it and take the value 12, put it back in a of 0, right? So a of 0 is now modified or updated as 12. It is not going to have 11 anymore and here at this point. So a of 0 will now become 12 during the first iteration. Okay. Now, now you increment the value of I by 1. So the current value in I is 0. That is getting added with 1. So new value in I will become 1. So we come to the end of the while statement. So wherein the control will be transferred back to this position, right? So when you come to the end while, the control will be transferred back to while statement. So we just go back to while and now we check for the condition with the new value in I. So new value in I is what? It is 1. So compare 1 with 4. So when you compare 1 with 4, you find the condition to be true because the comparison is if 1 is less than 4, you proceed, or otherwise go out of the while statement. So 1 is less than 4. So you take the value to be true here. The resultant value of this relation expression is true. So when it's true, we go enter the while statement body and we execute the set of statements inside the while body. So a of 1 is now moved with 21, right? And also you increment the value of I by 1. Now this will get repeated till the value in I becomes 4. So once the value in I becomes 4, the condition there again it is going to be true because we also check for equal to. Even if the value is equal, we proceed with executing the loop body. So we just execute the loop body wherein you pick the element at location 4 and modify it to 16, put it back, and obviously you also execute the next statement here as it forms the body of the loop and you increment the value in I by 1. So it becomes 5. So with this new value 5 in I, you go back to while statement and you check for the condition again. So condition here fails because I is now become 5. So condition fails. So when the condition fails, then you are going to be taken out of the loop. So you come out of the loop and you stop there. So this works fine. So this actually helps us traverse or visit every element of the array and also do some processing with the value that we have visited or traversed, right? I hope you understand this traversal method. Now let's see whether this algorithm works fine for all different cases. So let's ask for ourselves whether this algorithm is going to work for any kind of array. So this is the first question need to be answered once we are done with the algorithm, which is going to work fine for the array that we have taken, right? So we have taken all constant values there. We have assumed the size of the array to be 4. We assume that the starting index is 0. But is it the same in all cases? No. So the algorithm is not going to work for any kind of array. So why? Because we always assume in our algorithm that the starting index is 0. And we always assume that the size of the array is 5. Right? So this may not be the case always. We may have array of different sizes. We may have the range of index to be different, not necessarily always be starting from 0, right? So if the size of the array is large, then this algorithm is not going to work. If the index is going to vary, if the index is going to take some negative values, then if the index, even if it's going to start from 1, this assumption is not going to work. Then what are the changes that we could make? And the next question that we need to ask is, will this algorithm be able to do any kind of processing? No. The only process what we have done here is just adding. So it is just adding, doing some constant addition here. So this is the only process that could be handled by this algorithm. So how can we make this algorithm a general algorithm so that we could traverse, we could make the user traverse every element and do whatever process he wishes to do. So these are the changes that we need to make. So if you want to have a different range to be handled by your algorithm, then instead of having 0 initialized in I, make it as the lower bound. So whatever be the lower bound value, that will be assigned to I. So now I is going to be assigned with -2, right? And now coming to the condition. With this condition, we can say that our algorithm will work only when the size of the array is 5. It is going to check only till the location 4. If the value in I crosses 4, then it takes us out of the while statement. So it is not going to process other elements which are going to reside after this 4. So what can be the change that we could make here so that we can make our algorithm work in general? It is converting this or having u, that is upper bound, in place of 4. So you try to find out what is the upper bound. If upper bound is 2, then it is going to have check for value 2. So here in this case, I is going to be -2 and this is going to be 2. So between -2 and 2 inclusive of both, we have 5 elements, right? So -2, -1, 0, 1 and 2. Alright, so it works for this while loop will go into 5 different iterations anyhow, but the lower and lower upper bounds are different. So it is going to work for any range of index that the user declares, right? And making this process general, so I need not always add 1 with the actual array element that I visit. I may have some other process to be done with the element that I pick out from a location where I am now. So we just make this as general. It could be anything like adding, multiplying, dividing, or just finding a negation, any process, right? So we can, in general, we can write the algorithm's process. So whichever process the user wants to implement, he can do that with the element that he is visiting at that particular time. And this is not going to vary, because whatever it is, you get to go one by one. You keep incrementing at every step. So be it -2 or 0 in the lower index, lower bound, you get to just keep adding 1 to move to the next location. So this I equal to I plus 1 remains the same. So no change here. So this code, this algorithm, or part of the algorithm, converts this algorithm what we written in the previous case into a general one. So this is going to work for the array which actually can work for any range of indices and array of any length, right? And for doing any process that the user wishes to do. So this slide actually helps you understand how this general algorithm works. So that I told you already in the previous case, like previous slide. So you get to make this I as -2 here, so which is the lower bound, and this u is going to take the value 4. Now let us just try to execute every step in this algorithm. So initial value in I is -2, right? And the first iteration we check for the condition -2 less than or equal to 1. Here, sorry, this is not 4. I'm sorry. This is 1. I'm taking a different set of values here. The array has got only 4 elements, the index starting from -2 going till 1. So upper bound will be 1 and lower bound will be -2. and the process could be anything like incrementing, decrementing, multiplying, anything, any whatever process you want to have, you can just do that. So we leave it to the user. And here condition is being checked for -2 is less than or equal to, why it is less than 1. So condition is true here, so we enter into the loop body, we do whatever process we want to do here with this value 11 or this element which is present at location -2, right? And you then increment, we try to move to the next location by incrementing the index value by 1. So if you just increment the index value by 1, it becomes -1. So here that is the one which we want. After processing the element at location -2, we want to move to -1. Now this statement helps us to get this value -1 in I. Okay, we are done, and we again go back to the while statement. So we enter into second iteration, check for the condition, condition is true again, -1 is less than 1. So do the process with a of -1, which is 20 here, right? So a of -1 is 20. You do whatever process you want to do here, and then increment the I value. So incrementing I value now, the current value in I is -1, incrementing it by 1 will get us 0. So this is what the intended index is. So we are getting it right here. With this index value 0, you go back and check for the condition. Here it is 1 and 0, the condition is true. So process element at 0, a of 0, which is 9 here. So whatever process you want to do with this 9, you can do that and increment the index value. So when you increment the index value, it becomes 1 because it was previously 0. Now by adding 1, we get 1 in I. So with 1 in I, we go back to this while statement and again do the comparison. 1 is equal to 1. So condition is true. Do the process by accessing the element at location 1. So it is 18 here. So you take 18 and do whatever process you want, then increment as usual. So when you increment, I becomes 2. Then with the new value 2 in I, you go back to while statement here, and the condition here fails because 2 is not less than or equal to 1. So once the condition becomes false, you come out of this while statement. So you will be taken to the statement next to while statement. So you stop here. The next statement is going to be stopped here. So the tracing stops here, and you've seen that we were able to access every element in the array. So what will be the range of the indices? Just by having this as general initialization with L and checking for the condition I less than or equal to U, you'll be able to process or access every element of the array. So this is all about traversing the element. Now in the next video, let's see how to insert a new element, insert an element into the array that is existing with set of values that is stored in it.